Continue talking about the weather. Reports over the last couple of days about finding a statement, putting out into the public the fact that Earth experienced its hottest ever year in 2023. And not just every now and then a hot day, just about every day of the year was hotter than its historical antecedents. And we ended the year with a sense that climate change, global warming, is not slowing down, it is accelerating. Professor Guy Midgley of Stellenbosch University, now acting director for the School of Climate Studies at Stellenbosch University, with us now. Guy, good afternoon.
Hello, John. Thanks for having me.
Is this the thing that makes the people who are, if not denying the problem, certainly not tackling it with the urgency it needs, is this a sort of statistic that maybe makes them a little more concerned?
Well, I do think it does shift the needle, particularly with people who are sort of in the undecided category. I think the hardcore denialists, there's nothing you can really do to change their minds.
I've just got a WhatsApp from somebody, a voice note that I'm not going to play. Oh, what nonsense that it's the hottest the world has ever been.
Well, I get where that person's coming from. It's certainly the hottest that the world has been in, likely in the period of recent human history, certainly our civilization, modern civilization. But, the world has been hotter, but you need to go back hundreds of thousands to millions of years to get hotter temperatures. And going back that far, the world's a very, very different place. So it's nothing like the world that we're living in at the moment. So, yes, it has been hotter deep in the past, but then sea levels were tens of meters higher. We had no ice on the planet. It's a completely different planet.
So to go back to the original question then, is this sufficient to galvanize more action than we've been getting?
But I think there's a lot of action that's being galvanized because of the impacts of extreme events around the world. We're seeing flooding, wildfires, extreme heat events, and other forms of damage from climate change, super hot ocean temperatures. And certainly you're seeing a lot more concern and sort of expressed desire for action. The challenge, as we saw at the COP28 last year, was that the fossil fuel industry is buying themselves as much time as possible to eke out as much of the carbon market as possible. So this is the challenge that we face, and the transition has to, it's not going to happen immediately. It's going to take some time, and there's a lot of battling around how this transition should look and how to make it happen without it adversely affecting people who are dependent on fossil fuels, as we well know that there are many.
But you're not striking an optimistic note, but you are striking a more positive note than much of what I read, which is slightly more doomsday apocalyptic, or even significantly more doomsday apocalyptic, that the accelerating rate of global warming means that we're going to hit that critical figure of 2 degrees higher sooner than anticipated, which means we've got less time to slow down the acceleration and begin to reverse it, which increases the chances that we get to pretty much ongoing catastrophe.
Well, we're really on the edge. I don't want to sugarcoat the challenge that we face. We're seeing, for example, some really radical changes in the Southern Ocean, melting of the Antarctic ice, which is really worrying. I think people tend to forget that the warming atmosphere is really only about 3 or 4% of the total energy that we've added into our biosphere. About 95% has gone into warming the oceans. It's a massive effect that we've had on the oceans. And this year, because of El Niño, that surface warming has become sort of exacerbated. So now we've got a warm ocean that normally would have been absorbing some energy, which is not the case. And so the atmospheric temperatures are responding even more than normal. So 2024, this year, is going to probably be hotter than last year. And this is, we have, there's a lot of momentum that's built up inside our incredible biosphere. And we will pay the price if we don't act rapidly now.
And are we, in meaningful ways, acting rapidly?
Well, I think one of the biggest things that I'm seeing is this shift towards renewables, driven by the economics of renewables. As hard as the fossil fuel lobby is fighting, the cost of renewables is coming down. There's been a lot of concern about there's a limitation with regard to the mining and the resources that we need to follow a renewables path. That doesn't really seem to be a significant issue. Of course, we don't want to have to mine, the world out to have a renewable future. We want to reduce our demand as well as switch to renewables. So we have to do both of those things. But the lower cost of renewables is you can't really fight it. Once the economics takes hold, it will, these things go kind of in an S-curve. It starts slowly and then it accelerates, and you can't stop it. So that's my big hope.
Well, the IRP is trying to stop it with reducing new renewable energy to 6 gigawatts and pushing up gas energy to 8 gigawatts over the next time.
It's King Canute stuff. You can't do it. It's just not possible. I mean, we've seen South Africans importing 4 to 5 gigawatts of solar panels into the country. It's an unstoppable trend now, and that it makes all the sense in the world. There are many advantages from going this route, and it's happening around the world.
Talk a little bit more, Guy, because we got a few minutes before the news at 5:30 about cooling the oceans again, because again, we don't exactly. We know that a lot of damage is done. There's a lot of evidence around fish stocks, but some of it is fish are moving from traditional spawning grounds to new spawning grounds. So one area is losing what another area is gaining. But there are very obvious permanent impacts or near permanent impacts or potentially irreversible impacts happening to all sorts of things under and just above and on the littoral of the seas. I mean, what are the things that we could and should be doing to slow down the warming of the seas and start cooling it back down to more planet-sustained temperatures?
Well, I mean, reducing emissions and throwing CO2 out of the atmosphere has to be the case. I think, controlling what happens in the oceans, this is a vast system with just massive amounts of energy in it. There's very little, we are puny humans in relation to what the ocean's doing. I think some of the things we can be doing and should be doing is that we know that about 0.5 meter of sea level rise is dialed in no matter what we do over the course of the century. But we should be planning now for how to adapt to that 0.5 meter of sea level rise. There's no real excuse for ignoring that now.
Okay, so dialed in by when? Not 18th of February 2032, John, but dialed in by roughly what time frame?
Definitely between 2050 and the end of the century. So certainly, probably, hopefully, towards the end of my life, but certainly in the lives of our children, that sort of sea level rise is inescapable, no matter what we do.
Put that 0.5 meter sea level rise into practical impact for the city of Cape Town.
Well, when sea level rises 0.5 meter, it eats back at the coast, depending on the shape of the coast, by tens of meters, just because of the way that sea level works. So you would see really radical, erosion of all the beach areas around Cape Town. We're quite fortunate in South Africa that many of our coasts are quite rocky and would be resilient to this. But a lot of our ocean-facing cities, Durban would be particularly badly affected. And Cape Town, parts of Cape Town, Strand, Gordons Bay, those sorts of areas would certainly be suffering a lot of beach erosion under those sorts of conditions. And then you get effects where salt water starts to intrude into the soil water and the aquifer, which can be very, very negative. So things like growing vegetables on the Cape Flats could come under threat from those sorts of effects, salinization of the aquifer. And who knows what other things, we keep on stumbling across other curveballs. These complex systems are going to throw surprises at you. And we need, this is going to be a massive area of job growth where we need engineers, we need people who can think across sectors to come up with solutions about these things. This is going to be a massive area of growth over the next 20 to 30 years as we tackle adaptation to climate change. This is going to be one of the most important jobs that anybody can have, I think.
Professor Guy Midgley, thank you very, very much for talking to us this afternoon. Much appreciate your insights and expertise.